Hi, Data Ben here. Today we're going to cover data types in VBA. So what are data types? Data types are what you declare your variables as when you first declare them. So when you're doing the keyword dim, so dim word as string, for example, that's declaring the variable word as a string. So these are all the different types of variables that are possible in VBA. And it's important to note that you don't actually need to declare variables in VBA, but you always should. So when you have the one-line option explicit on the top of your VBA code, this forces you to declare your variables and is generally good coding practice, so you should always do this. If you don't enter the option explicit on the very first line of your VBA code, then and you don't declare your variables, then they will all be automatically declared for you as variants. This variant data type is the default data type in Excel, so in VBA. So you have, the good thing about it is it can contain just about any value that you want, but unfortunately it's also highly inefficient because of that. So a variant, if it contained just a number, would be quite a large 16 bytes of memory space. And if it was a string, it would be 22 bytes plus the length of the string on top. So variants are highly inefficient, but they can contain every type of data type within them. So think of the variant as a wrapper. And what happens is, for example, if you declared a number within the variant, it might morph to become an integer, let's say the number 30,000. So the variant would morph itself to become an integer, but it would, instead of being 2 bytes, an efficient 2 bytes, it would still be 16 bytes. Also, the maximum and minimums for variants will hit the maximum and minimums for whichever comes first, for if it's a currency, a decimal or a double number underneath, because these are the largest values that VBA itself can store. Although it's highly unlikely that you'll reach these variants if it morphs to, for example, a currency and it hits that 922 trillion number, then it will give an error. So that's the variant data type, the default data type for VBA. Let's look at the declared data types. So starting with byte, which is a single byte of space, is 0 to 255. Boolean is either true or false, so which is a very useful one, a switch to have, which is only 2 bytes. Integer is between the two figures there, negative 32,768 and positive 32,767. Single holds 4 bytes and is for decimal places. As you can see, it goes up to a number of decimal places there for a certain level of accuracy. A long is a very popular type to store numbers within, because it stores this 2 billion, negative 2.1 billion to positive 2.1 billion. So it's the most, and is also quite efficient at 4 bytes. So is a very popular way to declare numbers. Then you have double, which is up to another level of accuracy than single. And then decimal, which is a bit of an unusual one, which you may not use, which is for when you to actually use it. First of all, it's a large 14 bytes, but you'll see with a number possible that it goes up to a very large number and a very large number of decimal places. However, you do need to convert it to a decimal via this CDEC function. So you declare it as a variant, and then you can enter this number. You can then convert the variant into a CDEC, which will contain one of these large numbers. However, it's highly unlikely, again, you'll need this level of accuracy, so it's very rarely used. The next one is date, which spans from January the 1st, year 100 to December 31st, year 9,999. So we've got a lot of time left before that runs out. Then currency, which is the 922 trillion number, which is, again, for if you're wanting a very high level of accuracy. Sometimes when you go to start using large numbers, and this is for encoding in general, not just VBA, you start to lose some decimal places and some small fraction of numbers when you add them together or subtract them, when the numbers you're using are very large indeed, or go to a very high number of decimal places. So if accuracy is very important and you're using very, very large currency amounts, then this would be a good option. The next one is string, which is your standard declaring a string, so dim word as string, which can go up to 2 billion characters, but it begins with a minimum of 10 bytes and plus the length of the string. So you can take up a lot of memory by putting a lot of text into the string variable there, so it can quickly make you run out of memory if you're putting a lot of text into a string, which is worth keeping in mind. Next one is a fixed string, which is just the length of the string. So you can actually declare a string as, say, 5 characters, in which case it would be circa 5 bytes and maybe more efficient. So if you're just wanting to declare a string which just has, for example, A, B, C, D, E in it as 5 characters, and you know it's not going to change, then that's a more efficient way to declare that string. Finally, you have the object. Now, the object can be anything in Excel, as discussed previously in the object-oriented video. This can be the active workbook, the active sheet. It can be the Excel application itself. It can be the range. It can be a chart. So an object can be anything within Excel. In fact, anything that VBA can access itself. And this declaring this takes 4 bytes. So now we've declared the data types within Excel itself. So you can see here in this first block of code, we've got test variant as variant, test byte as byte, and so on, all the way down the list, matching the previous slide. The first thing to note is that you can see we have a fixed string here by doing the star multiply sign and then the number of characters we want the string to be. So 20 characters in this case. Below this, we have all of the variables assigned with the maximum values that are possible within these data types. So, for example, test byte we've set to 255 because that's the maximum number it can be, integers to 32767, and so on, all the way down the list. It's worth noting that some data types, such as date, won't even let you type an amount that's actually out of bounds. So for example, the lowest date is the 1st of January, year 100. But if I try and set this to 99, it actually pre-populates with 1999 automatically. And if we try and go above the maximum of the 31st of December, so 9,999, so that will work. But then if we try 10,000, instead we get an error message this time. So it's actually not possible to type a date out of bounds on the data type. Let's run the code here and actually see these enter into memory. So I'm going to add a breakpoint on the end subline so that we just get to the final line and can see everything that's in memory. And then I'm going to click the play button. And you'll see in the locals window underneath that we can see all of the variables with the actual values inside them, so the byte with the 255, and it actually tells us the data type as well. So another thing to note here is the object we set here was test worksheet. So we've decided to use a worksheet, the active sheet, and you have to use the set keyword when assigning an object to a variable. So this could have been active workbook or a range, or really any object within Excel. This would have been accepted. And what it does here, you can see in the locals window, there's a little plus next to it. You can actually explore into the variable. So you can see here the sheet name, sheet 1, and the many hundreds sometimes of different settings and variables within this variable test worksheet. It will morph to match the object that's been assigned to it. So that's worth exploring and clicking down the plus icons here down the tree to try and understand the object that's been assigned to memory there. Okay, so that's all of the data types. Let's see what happens when we run this and actually do a data type that's out of bounds. So I'm going to change byte to 256, and this shouldn't be allowed. So if I stop now and press play again, we actually get the overflow error. And if I click on debug, there we go, it's stopped on the 256 because it's only 0 to 255. So if I change this back and I click play again, it continues, and that's now fixed. So you can see that you will receive an overflow error if you type a number or type a value that's out of the range given for the data type. And this is very important to understand, because a thing that often happens in VBA is you may use an integer, for example, and this may be a counter, that's counting upwards for some reason, maybe in a loop or something like that. And you may actually forget that this has got an upper limit of 32767, and when the counter hits 32768, you will get that overflow error, and it's just worth remembering that it's worth checking the data type. So that's all of the data types within Excel, within VBA, or the basic data types, and you'll be using these over and over again as we move on to the next subjects in these videos.